Okay, today we're going to talk about the Big Tree Tech SKR version 1.4, and I'm going to point out things around the board and then explain a little bit more in detail as we go. But this is just a basic tutorial to explain to you what can be worked with on this board. So as you can see, the board for the SKR version 1.4 has a port over here, which I've marked with red and unmarked. That's for voltage and ground. This is your power supply. So you can either use 12 or 24 volts to run this board. And then your output would be for your heat bed right here. And then there's two extruders down here that equate to E0 and E1 for your steppers. You also have a fan port that you can control with a signal pin, as well as power outputs for either 12 or 24 volts that are located here, here, and here. Now, the steppers that I was just talking about, you have the ability to work with the X stepper, the Y stepper, the Z stepper, E0, or E1. Now, there's various types of steppers that you can work with, and these various types have different functionality. So the most basic stepper that you'll be working with, if you ever work with it, will be the A4988. We also have the DRV8825. Then we have a SPI stepper, which is the TMC2130. That allows you to do sensorless homing. So you would not need to use an end stop or an optical end stop in order to find the end stop for your X axis or your Y axis. We also have a TMC 2208. That does not have sensorless homing, but it is UART. Then we have a TMC 2209, which is UART and does have sensorless homing. We also have a TMC 2226, which does it as well for both UART and sensorless homing. And then finally, we have for bigger motors and more power, we have the TMC 5160. Now, when I talk about each one of these things, I've actually made individual tutorials that are in my playlist that you can look up and see how to configure. And there'll be examples of how they work. Over here, we have our X minimum. This is for our end stops. Our Y minimum, or our Z minimum. In addition to that, we also have a port that's special down here for the BL Touch. So it's got a servo set of pins, and then it has a set of pins for using the actual signal pin to judge where the surface is in your Z axis. In addition to that, we have runout detectors for filament here and here. And a runout detector looks like this. Basically, it's an end stop that gets compressed when you put filament through, and then is detected when the end stop is triggered or untriggered in this case, because there's no filament. In addition to the normal displays that you can work with, we have two different types of displays that we can use for ports. We have our EXP1 and 2, which can be used on the RepRap Discount Full Graphics Smart Controller. And then we have the previous version of that for the RepRap Discount Controller that both will connect here. In addition to that, the TFT display allows you to have touchscreen capabilities. All of these contain the actual ability to work with an SD card, as you'll see in my videos in my playlist. And in addition, we have a port down here for the TFT display that allows you to connect with a special cable to the TFT display. Over here, we have our thermistor ports. This is used to tell temperature. So we have one for the heat bed, and then we have two for the extruders over here. In addition, we have the ability to connect Wi-Fi to the board so we can communicate with it remotely. I personally don't use that, but I do use the serial peripheral connection over here for USB, and that allows me to actually connect via my Raspberry Pi directly to this. Now over in here we have ports for SPI, and we also have the SWD ports. These are used to load firmware. In addition to that, we have closed loop motor connections over here for the X minimum, or excuse me, the X stepper, the Y stepper, the Z stepper, E0 and E1. I personally don't recommend using those because they have the precision of an A4988, which is the lowest precision that you can get. So the only time you'd probably use those is in a earthquake zone. But here's the universe of things other than what I've talked about that can be connected. Obviously, there's a servo connection that can connect right here. And then we have our normal steppers, which are the NEMA 17 steppers. It can also use NEMA 23 steppers with the higher output steppers. So what I'm going to do next is actually show you how to look up the information and set up your board. So what I'm going to do is I'm going to go over to the web browser and I'm going to show you the actual website for Big Tree Tech. So over here I have the website for Big Tree Tech, and I've already got it on the Big Tree Tech for the SKR, because in that folder is the actual directions for the SKR version 1.4. And as you can see, there's a data sheet right here. This tells you about your chipset for your board. Now there's two different chipsets. There's the LPC 1768, and then there's the LPC 1769. That one's used for the turbo version of the SKR version 1.4, and it has a higher clock cycle, so you can compute more computations with the higher end chipset. So if I go back over here though, I can show you other information. There's a manual that will show you how to set up your board. It'll talk about a lot of the information that I've talked about. It'll talk about the actual jumper configuration. So if you want to load your board with USB power, you have to move the jumper, or you can leave it on the actual direct power. But for now, in this example, I'll show you with USB. So I'm going to go back and I'm going to show you how you can actually see what's on your board. So if you go over here, there's a pins file. Inside this pins file, it tells you which actual connections you can use. So you can see that your filament runout for E1 is right here, and it gives you pin numbers to each one of these. So now that we know all this information and we can see where everything is on the board, what I'm going to do is I'm going to show you how to set up the firmware. So I'm going to go over to the Marlin website and I'm going to go to downloads. First thing I want to do is actually download the firmware that's most current. This is for 32 bits, so we have to use the 2.0 version. The 1.1.9.1 version and the 1.0.2.2, those are used for 8-bit configurations. So I'm going to download this, and as you can see over here, by the way, you can see there's a Marlin bug fix. This is a nightly fix, as well as the 1.0 version or 1.1 version. So now that we've pulled those down, I also want to show you example configurations. So I'm going to click on View Download. Inside View Download, you can see that there's actual stuff about your configuration examples. So we're going to download that as well. So once these are both downloaded, we're going to go over to our desktop for our downloads folder, and we're going to right click on this and we're going to say extract all. So let me find the extract if it's fully downloaded. Actually, that's an open version right now. Let me go back and see in our downloads folder. Sorry about that. So I downloaded it a second time, and I also downloaded the configs a second time. So this is actually going to save us some time. So I've extracted these by right clicking and saying extract all, which is right here. So I'm going to click on this, and then inside here, and this is called extras, pardon me, not extras, configs, examples. These are all the configurations that you can use with your board. Now these are designed for different types of printers, so they do it by manufacturer. So in this case, the most common one is the Creality. And inside here you can see that you have your Ender 3, your Ender 3 Pro, then also you have your Ender 5 Plus. I need to point something out though. Inside this file, if I open it up, you can see that down here for motherboard, they do something strange with pins. This is set up for a particular type of hardware. In this case, it's a ramps board. So I'm not going to show you this example at the moment because the ramps board is probably not what you want to use for this printer. But at least you know why. If you use this, it might be confusing because they're realigning pins inside this file. So I'm going to close out of this and I'll show you real quick how you would actually use these. You would highlight it, you'd right click and you'd say copy. Then you'd go back to your downloads folder, and inside your Marlin folder, you would go one level deeper, then go into the Marlin folder and paste them right here. I'm not going to do that at the moment, just so you can see how to configure this. I have multiple examples of tutorials that I'll put in the actual description of this video so that you can see the different ways to configure individual things. But for now, we're going to go over to VS Code. Inside VS Code, we're going to click on the Explorer. Then we're going to open a file. Then we're going to go to the Downloads file, the Marlin file, the second Marlin file, and then select folder. This will open up the entire project for you. So some of the information that you're going to have to keep in mind is this is a default configuration for the ramps. So we're going to have to change things. So in order to do that, I'm going to go first over to my Marlin folder, my source folder, my core folder, then boards.h. Inside here, I'm going to search on SKR 1.4. So it's going to be _1. And that should bring us to the first one. Now notice that it says LPC 1768. The board I'm actually working with is the LPC 1769 for the chipset. So we have to get the turbo version down here. So I'm going to highlight that and copy it. Once that's complete, we can close out of the boards file, minimize the core and source, then go to configuration.h. Inside here, we'll search on motherboard, and we'll highlight where the ramps is, which is the default board, and paste our version over it. Next, we need to actually change the serial port. In this case, we're going to do -1. And I would set up the actual TFT display, but I show that in other videos, so I'll let you look at my playlist. Now, keep in mind, a lot of the videos I've done have become slightly stale due to changes that occur in either the Marlin firmware or in the firmware that they use for the TFT display. So I'll be updating those as they change. So if there's not a configuration file in the TFT display, at least it shows you the process for setting it up, because when I early on did these tutorials, I was unable to have those files because they didn't exist. So what I'm going to do next is I'm actually going to show you, after I get this fixed, hang on a second. This is incorrect. It's actually, whoop, this is not working very well, so I'm going to cut it. It's actually -1. I'm having a little bit of an issue with my keyboard. But in order to set up the actual build for this, what we need to do is actually click on platformio.ini. And our chipset is actually not the Mega 2560. Our chipset was actually under source core boards right here. So I'm going to copy that and paste that into our platformio.ini. So it's going to go right here. Now you may also be able to find that by doing a search and then looking for SKR _14. It may or may not show up down here, but we already know where it's coming from. But for other boards such as the SKR Pro, this should be easy to search for. So as you can see, here's the environment for the SKR Pro. So now that we have that set up, what I normally do before I build is I click on the clean for the garbage can down here. And this allows us to clean out the previous build that may exist. And then I can click the checkbox. This is a normal build. Now, if we're connected via USB, we can actually upload it. So I'll show you how to do that real quick. So if I transfer over to the desktop for a second and I connect the actual USB cable to our configuration, we can actually set that up. So I'm going to connect this, and as you can see, it's not powering up because it's set to direct power. So we need to move the jumper for USB over to here, so it's the 2 pins below. Now it will power. So what we can now do in VS Code, because we're connected, is we can actually use that way to load with an upload. So I'll show you real quick over here what's going on. On previous builds that we did on this board, you can see that it says firmware.cur in capital letters. That means the current firmware build. So that was loaded recently. In a moment, I'll show you the change. So I'm going to click on VS Code for a second, and I'm actually going to use the upload button, which is this arrow right here, which will build and compile all the unique files and then upload it to the connected board. So I'm going to click on that. This may take a few moments to actually compile. It might be upwards of 30 seconds depending upon what kind of computer you're using. Unfortunately, this I think is a 8-core, so it's kind of quick. But if you're interested in knowing more about that, I'll show you. For now, just remember that no one's paid me or sponsored me to do this tutorial, so I will be placing Amazon affiliate links in the description for your convenience. So I'm going to go over to what's known as Pronterface, and this is my way of testing to see if it works. But in order for me to test this, I actually have to load the firmware still because it's on the drive. So if I click over here, I'll show you what I'm talking about. We have firmware.bin. What that means is this is the binary file that's going to load, and it will be renamed to firmware.cur. So watch the time on this. It says 3/28/2021 at 12:01 p.m. So I'm going to go over to the desktop and show you how to do that real quick. So what you need to do is actually pull out the power, then reinsert the power, and you'll see a flashing light that should appear on your board. It will be loading the firmware. And then in a moment, you'll be able to go back over to your SD drive or USB drive and see what's occurring. So I'm going to do that and show you what's occurring here. So over on my computer, you can see now it says firmware.cur and it has that time. So it's actually loaded the firmware. Now, if you have multiple SKR boards and you want to actually load multiple ones, a little trick you can use is renaming this back to firmware.bin, and then what you can do is reload it so you can load it on multiple machines. So I'll show you a quick example of what's occurring. So if I click over on Workbench here and I unplug and then plug it back in, what will happen on the actual computer when you look at the USB drive is it'll reload the firmware. So if we go to the desktop and I click on the actual folder for that, you can see now it's firmware.cur again. That's because it reloaded again. So now we're going to test it. And so one of the quick tests that I like to do is I connect, but unfortunately it says COM port 1. The reason that that's occurring is if we go over to Device Manager, we actually have a different USB connection for our COM port. So go to ports, expand this, and the other one is COM port 13. So that means we need to change our COM port from 1 to 13. Now we can connect to it. So as you can see, it says connecting and printer is now online. So one of the tests I like to do is actually type M119 and press enter. And what you're seeing here is actually, it's telling you the board is responding back. So your X minimum, your Y minimum, and your Z minimum are actually showing you that they're triggered. And the reason that is because there's nothing connected to them. So let me show you real quick how to fix that for the X stepper. So if we go over to the workbench for a moment and we take out a stepper like so, we can actually connect the cabling to that and set it up. So I'm going to grab a cable real quick here and I'm going to connect it like so. I'm then going to power down the board so you can see what's occurring. So I'm going to take the power out, and we need to know where these go. And I can tell you from previous videos that voltage is on top, and you can just connect like so. So red wire is voltage, black wire is ground, and green wire is signal. And I'll show you how to confirm that real quick. So if we go over to the web browser, let me bring this up so you can see it. And we go over to Big Tree Tech. It says 5 volts, ground, and then our pin number. And by the way, our pin number, if you look over here, I can show you that that's associated with our pins file. So if you go to the source, pins, LPC 1769, and then you go and find the turbo, inside here, you won't see any information initially. The reason that is because it's linked to another file. So it's actually linked to the SKR 1.4. So to find that, it's actually in the LPC 1768 because they share pins. So if you click on this, you'll start to see pins. Now there is a common folder for it up here. That's also linked in here. But you can see that the X minimum pin is going to be P1_29. So if you ever need to swap pins, you can actually swap the numbers, but you have to do it for each one that you're doing. So if you were to swap your E1 diag pin, it would have to become 29 and this would have to become 25 because the duplicate pins may cause issues with compilation. So if you like my tutorial, please press the like button and subscribe. And remember, I have a full playlist in my playlist for the SKR 1.4 where you can look up how to configure each one of these things. So thank you for your time and take care.